Okay, any questions from what I did last time? Anything from the last lecture? What I want to do is start with an example of converting from degrees to radians and vice versa. So suppose I have 270 degrees, and how do I convert it to radians? Well, in order to convert 270 degrees into radians, you multiply by what? Pi over 180 degrees. And if you do that, then what do you get? Well, I guess this is 3 and 2. You divide by 9 basically, so you get 3/2 of pi. Yeah, you can write 3 pi over 2 as well. And the other way would be, for example, 11 pi over 6. Let's say this is in radians. And then in order to convert it to degrees, you multiply by what? 180 over pi. And then when you do that, you basically get what? Pi cancels out. 6 goes into 180 how many times? 30. So this is 330 degrees. Okay. So one fact that I want you to remember from trigonometry is the following. Suppose I have a circle and let's say this is the center, and let's say I take a sector of this circle. So what do I mean by a sector? I mean the region right here. Let's say the area of this region is denoted by A, so that's the sector of the circle. And let's say the measure of the central angle here is theta. So theta is the central angle here. Then what is the formula for the area of the sector? Well, one thing you want to remember is that the area of a sector is proportional to the angle subtended by it. Okay? So what that means is that if I divide the area of the sector by the angle subtended by it, that ratio is the same as, well, what area is subtended by the angle 2 pi? What sector is subtended by the angle 2 pi? Well, it's the entire sector, which is the entire circle, right? What's the area of the entire circle? Pi r squared. So the ratio of the entire sector and the angle it subtends, which is 2 pi, is the same as A over theta. And so what is A? Well, A is then half r squared theta. So that's the formula that you need to remember. The area of a sector of a circle of radius r is equal to half of r squared times the angle subtended by the sector. Is everybody okay with that? Okay, so that's just a fact that we are going to use later. Okay, so now it's time to tell you or review the definitions of the trig functions. So how do we define the trig functions? Let's take a circle centered at the origin. So that's the x-axis, that's the y-axis, and okay, so this is the center, and that's the origin. So this is a circle of radius r, centered at the origin. Here's our x-axis and y-axis. So we know what an angle is from last time. So let's say I have an angle, and the angle is, the terminal side of the angle is this one. Okay. So this angle is the this line, or this ray is the terminal side of the angle theta. So the angle theta could be many of the angles, right? It could be the angle, it could be this angle here, right? It could be the angle from here to here, right? It could be the terminal side of the angle. I can go round and round and round many times and come back here, right? Is everybody okay? So all I'm saying is that whatever the angle theta is, the terminal side is the side that I drew. Okay. So whatever the terminal side of the angle theta is, it's going to intersect the circle at some point, right? So what I'm going to do is make a vertical line from that point onto the x-axis. So what it does, it creates a right triangle, and this right triangle, by the way, has this angle right here. This angle is the angle between the this angle is the acute angle between the x-axis and the terminal side. Okay, the acute angle between the x-axis and the terminal side. Now there are names for them, right? Anyone remembers the names? This is called the reference triangle. The reference triangle for theta. And what's the name of this angle here? This is the reference angle for theta. Okay, now let's say the point here is the point P, and the coordinates of that point are given by x and y. The point P is the intersection of the terminal side with the circle, and the coordinates are given by x and y. So what is x here? X is the horizontal distance. X is the horizontal distance of the point from the y-axis, right? So x is in my right triangle, reference triangle. What is x? X is this side here, right? You agree? And what is y? Y is this side. And what's the length of the hypotenuse? Well, the length is r, right? Because it's a circle of radius r. Okay? So then, what's the definition of cosine theta? What is cosine theta? Cosine theta is the adjacent over the hypotenuse. So this would be the adjacent over the hypotenuse. Adjacent of what angle? The reference angle, theta. The reference angle of theta. And what is that? Well, that's just x over r. Okay. Same way, what is sine theta? Sine theta would be the opposite over hypotenuse, which would be y over r. Is everybody okay? So cosine theta and sine theta are defined by this formulas here. Now, what would be the definition of tangent theta? Well, tangent of theta will simply be the ratio of sine and cosine. In other words, if you take the ratio of sine and cosine, what do you end up with? You end up with opposite over adjacent, right? Which means that you get y divided by x, right? Y divided by x. How do you define cotangent? Cotangent is just the reciprocal of tangent, right? So cotangent would be adjacent over opposite, or you can say x over y, right? How about secant theta? How do you define secant theta? Reciprocal of cosine. Cosecant would be the reciprocal of sine, right? So we can. I'm going to write down all that in a bit. Well, maybe I should write it down. Write that down right now. So basically, what would be tangent of theta? Tangent of theta, by definition, this is the ratio of sine theta over cosine theta, which is the same as opposite over adjacent, which is y over x. And then what is secant theta? It's the reciprocal of cosine theta, which is the same as hypotenuse over the adjacent, right? It's the opposite of cosine, and then in terms of our symbols, it is what? It is r divided by x. Sine theta, sorry, cosecant. Cosecant theta is 1 over sine theta, which is the hypotenuse over the opposite, which is r over y. And the last one, cotangent of theta, it's 1 over tangent, which is another way of saying that would be it is what? The adjacent over the opposite, which is x over y. You also realize that this is simply cosine of theta over sine theta, right? So notice one thing, that once you know the values of sine and cosine at an angle, do I know the values of the other ones automatically? Yeah, all I have to do is just take the reciprocals or the ratios of the two. Okay, so those are the definitions of the trig functions. One thing you might be asking is, okay, the definition of sine and cosine, right? It depends on the radius, right? We defined the cosine value to be x over r and so on. So you might be asking, hey, if I change the radius, if I have another circle, will I get the same values of cosine theta and sine theta, right? And what's your answer? If I take a bigger circle, and if I still have the same angle theta like I have here, would I get different values of cosine and sine? No, I mean, if I did, then this would be entirely waste of time, right? Because we wouldn't be talking about these functions if that was the case. So how do I know that it doesn't matter what circle you have, these you will get the same values for sine and cosine? Well, let's just look at it for a second. So let's say I have one circle, and then I have another one. And let's say this is the x-axis, and this is the y-axis. Okay, so let's say that I have an angle which looks like the following. Okay, so let's say this angle is theta. Okay, the inner radius, let's say the radius of the inner circle is R1, the radius for the outer circle is R2. Okay, and then this point here is the intersection of the terminal side of theta with inner circle. This is the other point here. Let's say the outer point here is P2, and it has coordinates x2 and y2. And let's say the inner point here is this one here is P1. It has coordinates x1 and y1. Okay, again, you make triangles from this point, vertical lines onto the x-axis. Same thing from this point. Okay, so then I get for the inner circle I get a reference triangle, for the outer circle I get a reference triangle, and I also have the same reference angle, right, for both of them, which is what? Which is this one. The reference angle is the same for both of them. Okay. Now notice that which one is x1? X1 is this side, y1 is this side, y2 is this side, and x2 is the bigger side here, right? So what is cosine of theta for the inner circle? Cosine of theta for the inner circle is what? x1 over r1, right? And sine of theta for the inner circle is y1 over r1. Now, for the outer circle, what is cosine theta? x2 over r2, right, for the outer circle, and this would be y2 over r2 for the outer circle. The question is, are they the same, right? Can someone tell me why they are the same? Why are they the same? Because, yeah, but why? Why is that the case? How do you know that these ratios are the same? Similar triangles, right? Because if you look at the two reference triangles, right, don't they have the same angles, equal angles? So they are similar triangles. And if you have similar triangles, the ratios of corresponding sides are equal. So then we know that by similar triangles. So this we know because of similar triangles. Okay, so that justifies why my definition of trig functions are well defined. Okay, so that's the definition of these trig functions, and we see why this is a well-defined. These are well-defined functions. Now that we know that radius doesn't matter, let's take radius to be 1. Okay, so let's take radius to be 1. So let's say I have a circle of radius 1 here and centered at the origin, and so this is the origin here. Now notice what happens when the radius is 1. This point is then what point? Is the point 1, 0, right? This point here is the point 0, 1, right? This point here, this point here. What is this point here? Negative 1, 0. And this point here is 0, negative 1, right? Now, if I have an angle let's say this is the angle theta, terminal side for the angle theta. Then this point, let's say, has coordinates x and y, right? So what can you say about cosine of theta then? So this side is x and this side is y. What can you say about cosine theta then? Cosine of theta is what? X over 1, which is the same as x. And sine of theta is exactly y. So when you have a unit circle, then basically we are saying the coordinates of the point P are given by cosine theta and sine theta, right? So if you look at the intersection point of the terminal side of theta with the unit circle, then the coordinates of that point are given by the value of cosine and sine theta. Okay? So that's what happens when you have the unit circle. But also from here we can also come up with a couple of special values. What's the value of cosine theta when theta is 0? So what I'm asking is, what is cosine of 0? What is sine of 0? What is cosine of 90 degree is the same as pi over 2, right? Remember, pi means 180, so 90 would be pi over 2. So what is cosine pi over 2? 0. Sine pi over 2 would be 1. Okay. What would be cosine pi? Pi means 180. Would be? Cosine of pi would be what? Now the terminal side is on the negative x-axis, so the intersection point is right here where cosine would be -1 and sine pi would be 0. And also we can write down what is cosine 3 pi over 2. Well, that means we have this angle here, and the terminal side is the negative y-axis, so we get the point 0, -1. So we see that cosine would be 0, and then sine of 3 pi over 2 would be -1. Is everybody okay with that? So these are some of the values of these trig functions that we immediately get from the unit circle. Is everybody okay with what I just said? Okay. Now, how about some other values of these functions? Well, usually, in any trig course, you are asked to memorize the values. You're supposed to know the values of these trig functions at multiples of 30 degrees, 45 degrees, and 60 degrees, right? So let's see if we can try and find those. Or, let's see if we can memorize those. So this is, again, the unit circle. So let's say this is the unit circle again. You know what? If you don't mind, I'm going to delete that. I am going to make a bigger circle. Okay. So here's okay, so this is still the unit circle. This point is 1, 0. This point is 0, 1. This point is negative 1, 0. This is 0, negative 1. Now, let's make 45 degrees. 45 degrees will mean something like this. So 45 degrees means pi over 4, right? And what is 30 degrees? That's pi over 6. So let's say pi over 6 is this angle, pi over 6. So that's 30 degrees. And then what is pi over 3? That's 60 degrees. So this would be pi over 3. And so we get the points here, here, and here. If I want to know if I want to know the values of cosine theta at these angles, all I have to know are the first coordinates of these points, right? So what are the coordinates of these points? So each one has 2 coordinates. That's not strange. This one will have 2 coordinates. Everybody agrees with that? Okay. Each one is a fraction. Okay, so each one is a fraction. So I know that each one would be a fraction. And in fact, each one is divided by 2. Each one is divided by 2. So all of them have divided by 2, but I need to know what are the numerators. Well, there is a simple trick to remember what are the numerators, which is the following. The numerators goes like this. You go 1, 2, 3. So 1, 2, 3, and then you go backward. 1, 2, 3, and then you take the root of the numerators. So you take the root of all the numerators, and there you go. You have all the coordinates you need to know. Of course, the root of 1 is just 1. Okay, but just so I'm saying the same thing for all of them. That's what I have. So again, 1, 2, 3, 1, 2, 3, and then you take the roots of all the numerators, and these are the coordinates. So then I can read off what's the cosine of 30 degrees. So what is cosine of pi over 6? Well, that's just the first coordinate, right? The first coordinate. What is that? Root 3 over 2. What is sine of pi over 3? Well, that's the second coordinate of the point at the angle pi over 3. What is that? Root 3 over 2. What is sine of 45 degrees? That's root 2 over 2. Is everybody okay with that? Pretty easy to remember, I think. Okay, so suppose you need to know. Let's do an exercise. Suppose you need to know the value of the sine function at 11 pi over 6, right? It's a multiple of pi over 6. How would you find the values of these functions at multiples of those functions, pi over 3, pi over 6, and pi over 4? Well, it's pretty simple. What you do is you use symmetries. First of all, 11 pi over 6, what I'm going to do is write 11 pi over 6 in the following way. 11 pi over 6. I am going to look at what's the closest integer to 11, which is a multiple of 6. 12. So I'm going to write 11 pi as 12 pi, but that changes quantity, so I'm going to subtract pi and write it this way. And then I'm going to write 12 pi over 6 minus pi over 6, which is 2 pi minus pi over 6. Now I know exactly what that angle is. Let's go up. Remember that this guy, remember I have the pi over 6. So what's the position of 2 pi minus pi over 6? Well, it is exactly the opposite of it is the reflection of that point, right? Let me release it there. So this would be 2 pi minus pi over 6 exactly, right? Or which is 11 pi over 6. Because 2 pi minus pi over 6 means you go 2 pi units counterclockwise and then pi over 6 clockwise, right? So you go like this, 2 pi, and then you go back by pi over 6, which means that these 2 points are reflections of each other by symmetry. And so what are the coordinates of this point here? The coordinates would be what? The first one would be what? The first one doesn't change, right? Because it's the first coordinate, x coordinate, right? This would be root 3 over 2. But because you're reflecting across the x-axis, the y coordinate would become negative half, right? Well, now we know exactly what is sine of 11 pi over 6 is. It is what? Minus half. Is that making sense? So you can follow the same strategy to find the values of sine and cosine at any multiple of any of those angles. Okay? Alright, so any questions so far? Any questions, anyone? A couple of more facts here. First of all, going back to this unit circle here, remember cosine theta gives you the first coordinates of the points on the circle, right? And notice that the first coordinates vary from -1 to 1, right? If you look at all the points on the unit circle, the first coordinates vary from -1 to +1, right? And cosine theta gives you the values of the first coordinates, right? So then I can say that cosine theta is where? The values of cosine theta would be between -1 to +1, right? How about sine theta? Well, sine theta gives you the second coordinates of the points, and the second coordinates also vary from -1 to 1, right? So you get -1 sine theta here. Alright, so that's done. Okay, a couple of more facts about the trig functions. Suppose that I have the unit circle again, and x-axis, y-axis, and if I have, let's say, an angle theta, right, angle theta, then what is the theta plus or minus 2 pi? What's the terminal side for theta plus or minus 2 pi? Well, notice that theta plus 2 pi would be what? Like right here, right? And if I take theta minus 2 pi, still I get the same terminal side, right? So my point is I get the same terminal point, so the value of cosine theta plus or minus 2 pi is what? Cosine theta. The value of sine theta plus or minus 2 pi is sine theta. You agree with that? Just because they have the same terminal sides. How about theta plus pi? See, if I have theta plus pi, what angle do I get if I... So this is theta plus pi, okay? So if you know the coordinates of this point are x and y, what do you know about the coordinates of this point? It's negative x, negative y, right? So that tells you cosine of theta plus pi is what? Cosine of theta plus pi is negative cosine theta. Sine of theta plus pi is negative sine theta. In fact, it works no matter what theta is. Even if theta is not what I have there, even if theta is in the second quadrant, third quadrant, fourth quadrant, still this identities will work. Also notice that let me make a triangle here, right triangle, and so let's say I have a right triangle. This is theta. So what's the measure of this angle? It's pi over 2 minus theta, right? So then notice that cosine of pi over 2 minus theta is what? Cosine of pi over 2 minus theta. So what's the opposite for that angle? Well, what's the adjacent for that angle? Let's call this... let's label this these sides as B here, A here, and C here. So what's cosine of pi over 2 minus theta? That's B over C, right? B over C, you agree with that? Because that B is the adjacent for that angle. For the angle pi over 2 minus theta, what is the adjacent? The adjacent is B. Hypotenuse is the same C, right? Well, so I know that this is going to be B over C, but notice that B over C, for the angle theta, B over C is what? Opposite over hypotenuse, right? B over C is the opposite over hypotenuse for the angle theta. For the angle theta, B is the opposite. So that's actually the same as sine theta, right? You agree with that? Sine of theta would be B over C. Cosine of 90 minus theta would be B over C as well, right? Same thing happens for sine. Sine of pi over 2 minus theta. Well, for the angle pi over 2 minus theta, what is the opposite? Opposite is A. So it's going to be A over C, but A over C is the adjacent for, A is the adjacent for theta, so this is what? Is that making sense? In fact, these two will work even if theta is not an acute angle, okay? Whatever theta is, these identities will still work. Okay, any questions on that? Now, some other identities that you need to know is, what is cosine of negative theta? Well, that's pretty easy to see. If this angle is theta, right, what is negative theta then? Negative theta would just be something like this, right? Negative theta. And these 2 points will be the opposite of each other, right? Reflection of each other. So what are the coordinates here? X comma negative y. So basically, what is cosine of negative theta then? This is the unit circle. Imagine this is the unit circle. So cosine theta gives you the first coordinate, right? So cosine of theta and cosine of negative theta are what? The same, because the x coordinates don't change. So cosine of negative theta is the same as cosine theta. But what can you say about sine? Sine of negative theta, well, if you look at sine theta is y, but sine of negative theta is negative y, right? So they are negative of each other. So sine of negative theta is negative sine theta. Are we okay with that? Is everybody okay with that? Okay, what are the other identities that you have to memorize? Is that a bad news? There are other identities that you need to know. So what are the other identities? Well, again, let's get a circle. And let's say this is the angle theta, and so this side. So remember, this is the unit circle, right? This is the unit circle. So this point is 1, 0. If this side is what is this side then? The length of this side is given by cosine theta, right? And the length of this side is given by sine theta, because this is the unit circle. And of course the hypotenuse is 1 because it's the unit circle. So then by Pythagoras theorem, what can I say for that right triangle? What can I say? Well, number one, I could say cosine of theta whole squared plus sine of theta squared is 1. Of course, usually this is the correct way of writing this equation. You take the cosine of theta whole squared plus sine of theta squared. But usually we use a bad notation when we study in our trig courses, which is usually people write what? Cosine squared theta plus sine squared theta. Why is this a bad notation? Well, it seems like I am squaring some value COS, right? But COS, it doesn't represent a number, right? Without you apply COS at an angle, you get a value, right? The COS by itself doesn't represent anything, right? So that's why it's a bad notation. And I emphasize that because sometimes in exams I see people writing cosine of 2 theta divided by cosine of theta, and then they say that cancel these two out, cancel these two out. Okay? Is that correct? No. See, cosine evaluated at the angle 2 theta is what is expressed here, right? Cosine, that's not a quantity. Okay? Okay, so that's the first identity we have. What's the second identity? Well, let's divide this equation throughout by cosine squared. So what do I get? I get, if I divide cosine squared by cosine squared, what do I get? 1. If I divide sine squared by cosine squared, I get tangent, because sine over cosine is tangent, right? So I get tangent squared. And then if I divide 1 by cosine squared, I get what? Secant squared. You guys agree with that? If I divide 1 by cosine squared, I get secant squared. So that's the identity. Identity number 3. Instead of dividing throughout by cosine squared, how about we divide through by sine squared? Well, then we get what? Cotangent squared plus 1 is cosecant squared, right? Okay, so that's identity 3. What else? 3, 4. You must have seen double. I'm not going to justify any of these identities. So this is the sum and difference formulas for cosine. So what is cosine of A minus B? Anyone remembers? Cosine A, cosine B, minus or plus? Plus. Sine A, sine B. Okay. What is cosine A plus B? That's cosine A, cosine B, minus sine A, sine B. How about sine? Now I think whoever answered this, you were answering this. Sine of A minus B would be what? Sine A, cosine B, minus or plus? Minus cosine A, sine B, and sine of A plus B would be sine A, cosine B, plus cosine A, sine B. Okay, 5. If you can write cosine A, cosine B as what? Notice that if you add up these two, what do you get? If you add up the first two equations, you get 2 cosine A, cosine B, right, is equal to what? Cosine of A minus B plus cosine of A plus B, right? But if you divide out by 2, then you get this, right? So if you add up the first two equations and then divide by 2, you're going to get cosine A, cosine B to be half of cosine A minus B plus cosine of A plus B. How about sine A, sine B? Sine A, sine B. Well, that would be half of, note that now if you subtract the second equation from the first, that's what you're going to get. So if I subtract the second from the first, I would be getting cosine of A minus B minus cosine of A plus B. So you're subtracting the second from the first and then dividing out by 2. Last one. Sine A times cosine B. What would that be? Well, you basically add the third and the fourth equations. So you get sine of A minus B plus sine of A plus B, and then you divide by 2, and that's going to give you that. You're going to use this extensively in Calc 2 for sure. We are going to use it a little bit also. This is what, 5 or? This was 5? Okay, we got more. 6. Double angle formulas. What is sine of 2 theta? Anyone remember sine of 2 theta? 2 times sine theta cosine theta. Okay, how about cosine 2 theta? Well, there are 3 ways, 3 equations for that. It is, first of all, cosine squared of theta minus sine squared of theta. You can also write it as If you replace sine squared by 1 minus cosine squared, you're going to get this to be 2 cosine squared theta minus 1. On the other hand, the first equation, if you replace cosine squared by 1 minus sine squared, then you get 1 minus 2 sine squared of theta. So all of them are the same as cosine 2 theta. And number 6 can be obtained from the number 5, okay? Not number 5, I guess. Number 4. You can prove everything in 6 from number 4. Okay. Now, I'm not done yet. Well, this was 6, right? 7. We can write cosine. You see, from the second equation, I can solve for cosine squared. If I solve for cosine squared, what I get is the following: half of 1 plus cosine 2 theta. And if I solve for sine squared from the third equation, I get half of 1 minus cosine 2 theta. Is everybody okay with that? Do you want more identities? Is this enough? Okay, it turns out this is enough. This is all you need did I go over time? Okay. I am going to give you some time back next time, okay? I didn't realize I went over time. But we are done with trigonometry review almost. I'm going to do a few more examples with it. Those of you who feel uncomfortable about trigonometry, you must go over Appendix D exercises. Make sure you know how to do them. If you do not spend time on it right now, you will not be spending time on it in Calc 2 or Calc 3. And guess what? If you don't know trigonometry very well, you will be hurt in Calc 2, Calc 3, and this one, okay? You possibly fail Calc 2 if you don't know trigonometry, okay? So make sure you learn it now and don't wait for, later.